So today we are going to look into the explanation of the longest increasing subsequence using binary search. So we have an input array. So in this array we have to find the longest increasing subsequence, and we are going to use binary search such that the final time complexity for this sum is going to be n log n. So from this, what we will first do is we will mark all the indices of the array. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right. So we are going to apply patience sort on this. For that, what we will do is we will take two more indices. Now, why we are going to take those two more arrays? Sorry, we are going to take two more arrays. Now, why we are going to take two more arrays? I will explain soon. So one will be an array of piles with index of smallest element. All right. So this one we will take an array. Now we will take another array and we are going to call that as array of pointers for pointing to top element to the on the pile to the left. So this is going to be another array. For this is going to have the pointers pointing to the top element on the pile to the left. So how can we place these numbers? Now let's first think of these numbers as playing cards, and the patience or the game of patience, it basically says that you have to create multiple piles such that in each pile only small and playing cards or small numbers can be placed on top of bigger numbers. So if we start with the first pile will have, so we will take 3. 3 is the first card, so we are going to place 3 here, and then we will go to 4. Now 4 is bigger than 3, so 4 is going to be placed in the pile to the right. So it's a new pile which we are going to create. Now we have 1. So 1 is smaller than 4, so we can place 1 here, but patience sort takes the greedy effect and it is going to put the card, the 1, to the leftmost pile. So 1 is going to be placed here. The reason for this is if we place 1 on top of 3, then we can place the card 2 on top of 4. So that's 1 extra card. If, however, we place 1 on top of 4, then the card 2 has to be placed on another pile. So we have to create an extra pile. The patience sort also says that we are going to create the least number of piles. So that's why 1 is going to be placed on top of 3, which is the leftmost pile. So the next pile, okay, so here is the thing. So every time we put a card in a pile, we are going to put the index in here of that card. So we place 3, index of 3 is 0. So we are going to place 0, the index in here. Now 0, I'm also going to put 3 in here, which is going to denote the actual value of the card so that it's easier for us to understand. Okay. The next card is 4. So we placed 4 on a new pile. So 4 has an index 1. So we are going to place 1 here. 4 is basically the card, just denoting that. But this is going to be a new pile. So these are all the piles, array of piles with index of the smallest element. Okay. So the next card was 1, and we found that we are going to place 1 here. So here we are going to replace this with 1, which has an index 2. The value of the card is 1. Okay. And then the next card is 5, which has an index 3. So 5 is bigger than 4, so that needs to be placed here. Okay. So now we need to place 5 here, which has an index 3. Okay. While we are placing this, we also are going to keep a track of the this array. So in this array, we are going to place the pointers for pointing to the top element on the pile to the left. Why is this required? So what we need to do here is, before we placed 2 and before we placed 1, okay, what did we do? So first we placed 3, so we placed 3 here, then we placed 4. So when we are placing 4, which is here 1, 4 is actually pointing to 3 because that is the topmost element. Okay. So here we are going to take multiple arrays, multiple elements in this array. So the number of elements in this array is going to be the number of elements that we have here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So we are going to mark this as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay. So what we need to do is, when we place this 4 here, 4 is pointing to 3, right? So 4 has an index 1. So basically this is the position of 4, and 4 is going to point to 3, which has an index 0. So when we build this array, we are going to put fill all the positions with -1, which is basically going to give us the breaking point in future, and we will see why. Okay, so now we have all the values in here, which is filled with -1. Now we placed 4 in here, and 4 needs to point to 3. So 4, I think it will be even more easier if we add all the values here as well. So this is basically giving us 3, this is 4, this is 1, this is 5, this is 2, this is 8, this is again 2, this is 3, this is 12, this is 7, this is 9, and this is 10. Okay, so the black ones, these are the actual values of the array, and then above that we have written the indices of those values in the original array. And then I have this new array, which is the array of pointers for pointing to the top element to the pile on the left. And this here I'm going to say, so we placed 4. 4 is pointing to 3, so we have 4 here. 4 needs to point to 3, so we are going to replace this with 0. Okay, because this is the index, so we are putting the index values for pointing, not the actual values in there. All right, so the next thing we did is we put 1. So 1 doesn't really point to anything on the left because we don't have a pile on the left, so we are good. So we need to put 1 which has an index 2 here, and the actual value, we are good. The next thing we tried to put was 5, so 5 needs to go to a new pile, and this is going to be the new pile. So this is 3, the index of 5, which is these 3, so these 3 here, and then 5 needs to point to 4, which is the topmost element. So 5 here needs to point to 4. Okay, so five is going to point to 4, this index. Nice. All right, moving on to the next one. So we have the next value as 2, so we are going to put 2 on top of 4, so we are going to put index 4 here, and the value is actually 2, and 2 is going to point to the topmost element to the pile on the left, which is 1. So 2 here is going to point to 1, the value 1. Okay, so that's why we are going to point 2 to 1, which has an index 2. The next thing that we want to do is we are going to place 8. So 8 is bigger than 5, so 8 needs to be put in the new pile. Okay, so if 8 needs to be put into a new pile, this is going to be a new array. So it's another one, this is another one, this is the new one. So 8 has an index 5, and 8 is going to point to 5, which is the topmost element on the pile on the left. So we have 5 here, the index is 3, and 8 here, so this is going to point to 3. So 8 is going to point to 3. Nice. So now we move on to the next one. The next card is 2. So we are going to place 2 on top of, so 2 is smaller than 8, we are good. Now 2 is also larger than 1, so we have to find where we are going to put 2 on. So 2 is smaller than 5, but it is also equal to 2, so we can place 2 here. So here we are going to say 2, which is index is 6, value is 2, and 2 is also going to point to 1 because that is the topmost element to the left of it. So this 2 has an index 6, which is this one, and we are going to fill something here. Now that needs to point to 1, and 1 has an index 2, so we're going to point to 2. So the next element is 3. So we are going to place 3 somewhere. So 3 is smaller than 8, but 3 is more higher than 1, which is the topmost one. It's also bigger than 2, so we are going to place 3 here. So 3 has an index 7, the value is 3 here, and 3 is going to point to 2, so 3, this 3 here is going to point to this 2, which is index 6. Okay, now moving on to the next one. So the next element is 12. So 12 is bigger than 8, so we are going to place 12 here as a new pile, and we are going to say 8 is the index of 12, 12 is the actual value, and 12, so 12 is here, so we're going to remove that because we're going to fill it with something. So 12 is going to point to 8, the topmost element. So here 12 is going to point to 8, so 8, the index 8 is going to point to the index 5. 8 is going to be the index 5. You can see here, which has the value 8. Nice. Moving on to the next one. The next element is 7. So 7 is smaller than 12. Now starting from this left, we can see 7 needs to be placed here. So 7 is going to go here, and replace this with 7, which has an index 9, and we also are going to replace here 7 with the pointer to point to. So 7 needs to point to 3, so 7 needs to point to 3. So 9 index is going to point to index 7, so 9 is going to point to 7. Moving on to the next one, the next element in the array is 9. So we are going to put 9 on top of 12 because it's smaller than 12. So I'm going to replace this with index 10 having the value 9, and 9 is going to point to 9 is going to point to 7, so basically index 10 is going to point to index 9. Good. And now moving on to the last element, which is 10. 10 is bigger than 9, so we are going to put 10 here as another element here. So now we will have another element in this array, and that is going to be 10. 10 has an index value of 11, the value is actually 10, and 10 is going to point the topmost element on the left, which is from here we can see 10 is going to point to 9, so 11 index is going to point to 10, so 11 here is going to point to 10. So now we have placed all the cards in this um, pile. Okay, so we have all the cards in this pile. We have this array here which says how many different piles are there, and then we have this array here which basically says where are the topmost elements on each of the pile, pointing to the elements to the topmost element on the left of the pile at the time when the element was placed in the pile. So using this, we can find the total length of the longest increasing subsequence. The total length, the length of the longest increasing subsequence is going to be the size of this array. So that is going to be 1, 2, 3, 4, 5, and 6. So 6 is the length of the longest increasing subsequence. Now if we want to get any one of the subsequence, how do we get that? That's why we build this array for pointing to the topmost elements. So what we want to do is we will get the last the index in this array in the last position. So this array has 11 as the last element, and this is actually pointing to this, which is basically this element, right? So first is going to be 10, this element, and next the item before that is going to be whatever this element in this pointer was actually pointing to. So this is the index where it's pointing to. So this index is basically 10 here, which has the value 9. So the value is 9. Now 10 here has is pointing to the index 9. So 9 is pointing to this, which has the value 7. Okay. Next, index 9 has the index 7, so it's pointing to index 7. So index 7 is here, which has the value 3. Index 7 is saying that it is pointing to index 6. 6 is this index, which has the value 2. Index 6 is pointing to index 2, which is this, has the value 1, and index 2 is pointing to index -1, which is basically so there is no -1, so this is the breaking point. So this here is the longest increasing subsequence. Now let's see if it's true. So the first element is so they are saying the first element is 1. So we have the first element here, 1. The next element they're saying is 2. So we have 2 here. Next element they're saying is 3. So we have 3 here. Next element they're saying is 7. We have 7 here. Next element they're saying 9. We have 9 here. The last element they're saying 10. We have 10 here. So this is in fact the longest increasing subsequence, as we can see, 1, 2, 3, 7, 9, 10. All right.